Thank you. So my name is JJ, and I'm the co-founder and chief scientist of 2Pi, a startup company spun out from my group at MIT, focusing on innovative optics solutions. So we all live in an information era today, and we are receiving ever-increasing amount of information that actually being captured and processed using light. With the exponential growth of optical information, existing optic systems are getting increasingly large in size and more complex. This has become a showstopper for many applications. If you look at the optical system, it really hasn't changed that much over the past few decades. On one hand, you have glass lenses that offer high performance but require grinding and polishing fabrication. They are costly and not scalable. On the other hand, you also have plastic lenses, which can be fabricated by molding at very low cost, but suffer from performance and reliability concerns. On top of that, an optical system typically requires stacking several of these lenses together, piece by piece with careful alignment, resulting in systems with increased size, cost, and complexity. 2Pi has developed Metal Plus optics to solve this challenge. Our approach uses semiconductor fabrication and packaging technologies that have been matured in the IC industry to transform optics. Unlike traditional lenses that rely on curved surfaces to bend light, we fabricate tiny little structures or optical antennas on a flat wafer, and then use them to control light propagation direction precisely. As a result, they can be produced at high volume with low cost, leveraging standard semiconductor wafer fabrication technologies. Moreover, when it comes to assembly, we can stack and bond multiple wafers, each of them containing an array of these flat lenses, and precisely align them with lithographic accuracy. In the end, the wafer stack is then singulated into thousands of individual packaged lens modules, each with a form factor of a small chip. In this way, we can leverage industry-standard semiconductor packaging technology to realize large-scale parallel integration of optics with significantly enhanced throughput and performance. So here's a use case of our technology. So driver monitoring systems, or DMS, are basically small cameras installed on vehicles to ensure that drivers are not getting distracted while driving. And our technology enables using a single component flat optics to replace traditional stacked glass and polymer lenses. This significantly improves the thermal and mechanical ruggedness, which is critical to compliance with automotive regulations. In addition, our optics also offers enhanced optical resolution that improves detection accuracy and reduces false alarms. We have already delivered mass-produced optics to leading Tier 1 and Tier 2 suppliers in the automotive industry and received excellent feedback from our customers. A second use case example of our optics is in optical sensors for augmented reality and virtual reality systems. State-of-the-art AR/VR modules contain anywhere from 15 to 20 optical sensors to perform functions such as facial recognition, eye tracking, hand tracking, 3D sensing, and so on. When using traditional optics, the size and weight quickly add up. Using our technology, we offer sensor modules that are far more compact, lightweight, and can be seamlessly integrated with AR/VR headsets. At the same time, our optics also offers high resolution and a large field of view, matching that of human peripheral vision, which helps to render an immersive user experience that other technologies can hardly match. The performance of our sensor modules has already been tested and validated by leading OEM vendors, and we are now working towards mass production of this product. So in summary, what we are offering here is a platform technology that can empower applications where high performance, compact, and lightweight optical systems are needed. We are therefore eagerly looking for partners in consumer electronics, automotive, robotics, medical imaging, and beyond to explore this exciting technology. Thank you for your attention.
Thank you very much. Can you tell us a little more about how the optics are mass-produced, since you touched on that, and at what scale?
Sure. So we actually have a foundry partners that can allow us to actually produce these optics on 300 millimeter standard wafer technology. This is really compatible with state-of-the-art semiconductor mass production.
Okay, and tell us a little more about UAVs. Is there an application?
Oh, interesting. Oh, yeah, that's a great question. So I think that's UAV and robotics are generally sectors we really sort of want to look into. We got quite a bit of tractions in those areas. Essentially, what we're offering here is sort of a machine vision platform, hardware platform, that's miniaturized, lightweight, and also high performance. So we foresee there that potentially many applications in these areas here, for example, for UAV specifically, like lightweight cameras for surveying the surrounding environment, for collision avoidance, and just for all kind of other kind of essentially sensing applications like depth detection as well. So yeah, if there are any interest from the audience in these areas, I will of course be more than happy to discuss in more detail.
Thank you, Professor. Thanks.